In this video, we're going to be talking about solving rational functions. So, let's take this first equation for example. X minus 2 divided by x is equal to x minus 4 divided by x minus 6. This type of equation we've solved before, where in order to solve we're going to cross multiply. And be very careful when we're cross multiplying here to make sure we're distributing each term. So x minus 2 times x minus 6, distributing the terms, I would get x squared minus 6x minus 2x plus 12 is equal to x squared minus 4x. And from here I would need to simplify. So I'm going to combine like terms to get a negative 8x. And then I want to set the entire equation equal to 0. So in order to do this, I want to get the terms on my left-hand side over to my right-hand side by subtracting x squared and adding 4x on both sides, leaving me with 0 is equal to a negative 4x plus 12. Notice the x squares cancel, so I'm not going to have to worry about factoring. So I can just subtract 12 on both sides and then divide by negative 4, leaving me with x equal to 3. So now let's take this second example. 1/3 plus x over 2 equals 5 over 6. My first step here is I want to find the least common multiple between the denominators. So looking here, I see the least common multiples between 6, 2, and 3 are going to be 6. And so I multiply each term in this equation by that least common multiple 6. When I do this, I end up getting 6 over 3, 6x over 2, and 30 over 6, which all reduces down to 2 plus 3x is equal to 5. Now, I didn't have to write out 6 in the numerators. I could have went straight from 6 divided by 3 is 2, 6 divided by 2 would be 3, which multiplied to the numerator is 3x. And then 6 divided by 6 would cancel, leaving me with 5. But for your benefit, I want to make sure you see this in-between step. And then from here, I'm going to algebraically solve, subtracting 2 on each side, and then dividing by 3 to give me x equals to 1. So, using that same strategy, I'm going to solve this third example. Looking between my denominators, I want to find my least common multiple. In this case, the least common multiple is not a number, but an actual expression. So my LCM here is going to be 7 times 2 plus y. So I want to multiply each term by this least common multiple. Which, when I do this, notice the 2 plus y and 2 plus y will cancel, leaving me with 7 times 3y, which can simplify to 21y. 7s will cancel out here, leaving me with 5 times 2 plus y, which simplifies to 10. Now notice this is minus 5, so this subtraction sign needs to be distributed. Minus 5y is equal to, and nothing will cancel here, it will just multiply straight out into 28 times 2 plus y, which multiplies out into 56 plus 28y. And from here, I'm going to algebraically solve by combining like terms. This will leave me with 16y minus 10 equals 56 plus 28y. Add 10 to both sides, and then subtract 28y, leaving me with a negative 12y is equal to 66, which when I divide by negative 12, I get y is equal to negative 5.5, which when we plug back into context of the problem, we find it checks out. So the last example for solving is an inequality of rational functions. Once again, I'm going to solve this the exact same way by finding the least common multiple. Now notice the least common multiple here is going to end up being 2x times x plus 3. So I want to multiply every term in this expression by 2x times x plus 3. Which from here, when we do this, we see that 2 and 2 will cancel, leaving me with x times x plus 3, which would simplify into x squared plus 3x. This first term, the x plus 3 factors cancel, leaving me with 2x. And here the x's cancel, leaving me with 2 times x plus 3, which simplifies to 2x plus 6. And from here I would algebraically solve by combining like terms. And then setting the inequality equal to 0. I'm going to do that by subtracting 4x on both sides and subtracting 6 on both sides. And from here, factor into x minus 3, x plus 2, setting each of the factors to 0, and then solving. And I get the solution to this, that x is can be any value less than or equal to 3, and x can be any value less than or equal to 2. Thanks for watching.